let's have a look at how we can calculate the area underneath a graph. So I want to calculate this area, and there's no immediately obvious way to do it because it's curved. It's very close to a trapezium, but it's not quite the area of a trapezium. We'll see in the second year that we can approximate it using trapezia. So let's think, well, what can we do instead then? What we can do is we can try and use a similar trick to what we did with differentiation. We can approximate a small increase in area with a rectangle. So we're going to call that the small change in area. How would we calculate that? Well, we know that we have a height of y, and again we have a small increase in x. So I'm going to refer to that as delta x. Remember, lowercase delta means a small increase, a small difference. So we're saying that this can be approximated. Remember, it's not quite equal to it, it's an approximation. The small increase in area will be approximately y times the small increase in x. Okay, so that doesn't tell us much, but assuming that we know the function y, that will tell us that we can approximate the change in area divided by the change in x will be approximately the value of y at that point. Okay, so that's good, we can approximate it, but now we're going to apply a similar idea to what we did with differentiation. If we want to make this approximation better, we need to reduce x. So again, we're going to look at the limit as the change in x goes to 0 of our delta x, delta a over delta x. As that becomes infinitely small, as it goes to 0, then that's when we have, just like before, the dx, dA over dx. And that will now equal y. As that goes towards 0, it becomes a perfect approximation. So what has this told us? Well, this has told us that y is equal to the derivative of the area underneath the curve with respect to x. Well, that appears helpful, or at least somewhat helpful. Even if I don't know the area, I do at least know the rate of change of area, the gradient of the area, is the height of the graph. But I do know how to undo differentiation. Now that I know integration, that tells me that if I integrate the function y with respect to x, I will be left with the area. You can kind of think of this as a fraction that you multiply up by the dx, and then you'll get the integral of y dx is a. It's a bit more complex than that. We're actually integrating both sides with respect to x. But essentially, if you think of it as a fraction, it can just help you understand what's going on here. So it's saying if you integrate the function y with respect to x, you will get the area. We'll have a look in the next video at how that works in practice.